Okay, great. Well, good afternoon, and thanks to everybody, and thank you, Ron, for the opportunity. Thank you, everyone, for your time. I'm going to talk to you today about Circuitmeter and our technology and how the markets are evolving, applications, and the economics that are emerging as we bring Circuitmeter to market. Firstly, what is Circuitmeter technology? Circuitmeter is Internet of Things technology, if you will. It includes submetering hardware that merges energy measurement with internet communications and cloud-based energy analytics to provide an overall platform that measures and gets the energy information into a place where, as an organization, you can use it. This technology is going to be critical in the transition to net zero and the fight against climate change, because energy efficiency is one of the four legs of the whole clean tech table. We've got green generation, and we've got storage, and we've got smart grid technology. But the fourth leg of that table is energy efficiency. And I'm going to start just by looking at some of the major forces that are moving these markets forward that we all have to deal with in society. There's a combination of regulation, technology, and best practices that are all driving a massive sort of movement towards maximizing this energy efficiency on the road to net zero. First of all, mass electrification is going to be one of the biggest transformational forces our market and our infrastructure has ever seen. And we're going to have to meter everything to understand where we're wasting energy and minimize the associated operating expenses, and also to guide and optimize our capital improvement programs. Government regulations are going to require submetering. It's already happening. And also reporting on energy and carbon use, and as well in the markets, ESG policies that boards of directors and senior executive management teams are being required to put in place to show a proper commitment to the environment. And as we evolve towards a smart grid that I talked about, we're going to need to measure two-way flows of energy, two-way power flows that accommodate local solar generation, local building or factory located battery storage, EV charging systems, as well as demand management schemes, all of which will better stabilize the grid and give the owners of buildings and facilities a better financial performance. Now, what is Circuitmeter and how are we different? Well, essentially, our meters, our submeters with 48 circuit capacity in them, are entirely software and firmware driven, and we include internet communication in our meters. So you don't need third-party modems, data loggers, or any other equipment to get the data to the cloud. And then, in addition, we also include enterprise-level software, so that essentially once you install meters, you have all of this real-time energy data basically at the tip of your fingers through your browser. How is the world changing? As we speak. Well, the traditional world, mostly which we live in right now, is represented by the left pillar, which is a meter for every building, the utility bills you, and measures how much electricity you use, and you can get some basic data out of it. The middle data, energy use disaggregation, is where you're metering at the equipment level, so that you can understand throughout your whole building, your whole industrial facility, exactly how much energy in real time, and by real time we mean like at the 2-second level and even sub 2-second level, how every piece of equipment is working. And this is going to allow much more granular, precise energy analysis, and that's the key to identifying where energy waste occurs. Now, there's a number of ways that are emerging for us to turn this energy data money-saving opportunities. We're all familiar with tenant billing. It's been growing for 30 years in apartment buildings and residential applications. It's going to become basically across the board in commercial real estate. But I think that the continuous energy audit is probably the biggest item on this in this list of applications in the middle pillar, and with the second one being more and more demand response. We need to reduce how much energy we're using. We need to optimize optimize our capital planning as we continue to invest in upgrading our envelope and our mechanical equipment. And we have to pay attention to power quality and load management. All these things basically require data. Now, in a few minutes, I'm going to show you some examples of how that turns into really high ROI applications. But one of the keys is basically to measure everything, which is what Circuitmeter is all about. I'll just go quickly through these two slides, which is basically the only sort of commercial part of this presentation, which basically is just on the technology side. We've had third-party technology experts do market studies that show that we stand alone in this energy use disaggregation market because of our ability to measure 2-second basically energy levels and get all this information to the cloud and to the software where it's needed. And also, this graph is a major RFI conducted by a national level facility management company that showed that we're basically taking into account the whole platform, really quite a bit lower in cost than what things used to be. And yeah, it's great from a competitive point of view to be lower, but the really important thing is that this level of costing means that it can be feasible to actually go into a big building and literally measure everything that's going on in there. I mean, not at the plug load level, but we're going to commercial buildings, whether they're public sector buildings, city halls, arenas, big hotels, office buildings, and doing all of the common areas. It might be in a smaller building, 5 or 6 meters measuring 200 or 300 points, or it might be in larger buildings where we're measuring 600, 700, 800 metering points. But with all of this data, you can generate a really, really good engineering understanding of where operational costs and unnecessary use can be reduced, as well as putting real figures on where the capital equipment is operating inefficiently, and provide the data needed to prepare a business case that can allow you to go ahead with a pretty major capital rebuild, and also access government subsidies that are increasingly becoming available to do that. Just a little bit about what some of the features that are important. If you want accurate data, we're measuring voltage at a couple of 100,000 samples a second. This is what drives accurate energy and power data. But also it can be very important to get things like power factor, as well as operating time on, which gives you insight into life cycle costing and the degree to which any one piece of equipment is being used a lot or a little. I mentioned before about smart grid and storage. More and more, we're seeing net zero designs or high energy efficiency designs bringing solar generation onto the site, bringing battery storage onto the site. And so your meters need to be able to measure that two-way flow, and also basically inform demand management systems. You're also, as we assess, particularly existing buildings, we want to measure BTU outputs from, and in the future we're seeing more and more heat pumps being installed, and measuring the BTU input into building space, whether it's an apartment or a commercial space, requires BTUs, and being able to integrate that data into your overall energy data is also important. And of course, in this day and age, it's critical that you have cybersecurity, and that you're able to do this without compromising the local system. And that is one thing that is a feature of the Circuitmeter system, we can use the local system, and yet we're cyber secure, and we've not been turned down by any IT departments yet. So, how do we turn this data into value? Well, first of all, we can do, once we get the system installed and we generate a little bit of data, a few months worth of data, we can go back through and basically do a virtual walkthrough of a digital twin of the building and identify the equipment that's working, that's operating when it's not supposed to be operating, and take a look at why that is, fix the, address the low-hanging fruit, and also quantify the equipment that is working and working inefficiently and using energy, more energy than it should. I'm going to give you one example of a company, an American manufacturer that's operating globally, because I believe that this is really the state of the art in energy management. So I'm going to use, I'm not going to name them, but they've got manufacturing facilities in Malaysia, China, and a couple of places in Europe, as well as Mexico and many places in the United States. But they wanted to go beyond ISO 50001 and use Six Sigma principles and total quality management to implement forensic energy management, or real-time energy management. And the idea is that you measure the electricity of basically every machine, in their case in the manufacturing process, but also every piece of the equipment in the facility, and use the software to establish what is a normal energy use. And you also use the software to notify management when the energy use deviates beyond an acceptable threshold, and tell management that something's going on. This way, you can basically move into precision maintenance. You can identify in real time when equipment performance starts to deteriorate. And I think that every one of these principles, that apply in the industrial world, absolutely apply in the commercial real estate sector, as well as in the high density residential sector. In this particular example, that manufacturing company, as you referred to, conducted a pilot, and they spent 3 months collecting data, as you can see here. Then they spent 3 months analyzing the data and working out what they could change, what they couldn't change, fixing the easy changes, et cetera. And by the end of 6 months, they had actually reduced their energy consumption by 25%. And it was on that basis, that they made a decision to go global with the system. And to our knowledge, they're in the top quartile, or even the top decile in terms of energy efficiency, in terms of American manufacturing companies. So whether it's a hotel or a city hall, quantifying your data and then being able to use a magnifying glass with your software and look right in at what every piece of equipment is using, and particularly what's happening, for instance, at peak demand, is critical. As well, it's important to be able to track savings and make business cases when you get government money, or when you invest your own money. And then lastly, just a few examples on economics. Where we're going in brand new buildings, net zero office buildings, it only costs, perhaps $25,000 or $50,000 on a $25 or $50 or $30 million building to put in real-time monitoring. The idea is not to find low-hanging fruit, but to commission the building, make sure it's running at peak efficiency from the beginning, and to assure the stakeholders, both management and tenants, that everything is working properly. However, for retrofits, here's a 160,000 square foot building. They got a return on investment of about 700%. An investment of $35,000 yielded about the same amount annually in operating costs, as well as identifying chiller upgrades that ended up being a 4-year payback, ultimately because they had the data. And then for older buildings, of course, where there's a lot more energy being wasted, in this particular building, major hotel ended up with about a 1,700% return on investment, literally taking a third of the energy costs out potentially over a 4-year period of time. However, what happened was, although they started to implement some of the recommendation findings, COVID came along and everything got suspended. And during that period of time, they actually went back and redesigned with the data a different vision, and they're now in the process of converting the entire building into a net zero building where they anticipate getting even higher ROIs. So I'm just going to finish up and turn over to questions if there are any, to show very quickly what the data and the dashboards look like, and how all of this information can basically be translated into value. This kind of data was never economic before, and now it is. We're going to see this basically at the front end of every rebuild and every revaluation, whether it's commercial or industrial around the world. And the people who are doing it are basically using their initial experiences to forge ahead and get even more aggressive. Ron, I hope that I managed to stay within your time parameters, and I know I jammed a lot in there, but that's kind of the Circuitmeter story very quickly. We see this sector as being a critical part of the overall transition to high energy efficiency.